Hi, I'm Torben Janssen from thoughtsonjava.org. Today I want to talk about Hibernate performance tuning and give you 7 tips to avoid common pitfalls and to get the best performance out of your persistence tier. Let's get started. Tip number 1. Find performance issues with Hibernate Statistics. Finding the performance issues as early as possible is always the most important part. The main problem with that is that most of them are hardly visible on a small test system. They are caused by small inefficiencies which are not visible if you test with a small test database and only one parallel user on your local test system. That changes dramatically as soon as you deploy these issues to production. While the performance issues are difficult to find on your test system, you can still see the inefficiencies if you have a look at the internal statistics. One way to do this is to activate Hibernate Statistics component by setting the system property hibernate.generateStatistics to true, or by setting this parameter in the persistence.xml file. You should also set the log level for org.hibernate.stat to debug to get a few additional information. Hibernate will then collect internal statistics about each session, like the number of performed queries and the time spent for them, or the number of cache hits and misses. Let's have a quick look at an example. In this example, I activate the statistics in the persistence.xml file. You can see it here. Hibernate will now collect a lot of information about each session and write a log message with the most important metrics when it closes the session. I prepared this simple test case to show you the log output. As you can see, it's quite simple. It just fetches a list of author entities from the database and writes a log message for each of them with the first and last name and the number of books she has written. When you see this code for the first time, you probably expect that Hibernate performs only one query to get all author entities. But that's not the case, as you will see in the statistics. Here you can see Hibernate's log message with the most important session metrics. You can find the number of SQL statements and the time spent for their preparation and execution here. As you can see, Hibernate executed 12 queries to get all the required information. One query to fetch 11 author entities, and 11 additional queries to get the books each of them has written. That is a typical example of a n+1 select issue. It's the most common Hibernate-related performance problem. If you want to learn more about it, I have a free video course in which I show you how to find and fix these issues. I add a link to it to the video description. Okay, before I end this video, let's have a quick look at Hibernate's Statistics API. You already know this part from the previous example. I use the same query and log messages as before. Then I unwrap Hibernate Session Factory from JPA's Entity Manager Factory and call the getStatistics method. That returns the statistics interface, which provides you access to detailed information about the current session. You can, for example, use it to get the number of executed queries and the number of fetched collections. As you can see in the log output, the Statistics API provides more details than Hibernate's log message. The log message just told you that Hibernate executed 12 statements within this session. When you use the Statistics API, you can see that one of these statements was a query and that the other 11 statements were performed to fetch collections from the database. In this example, Hibernate had to initialize the book association for each author. Tip number 2. Improve slow queries. Slow queries are not a real JPA or Hibernate issue. This kind of performance problems occurs with every framework, even with plain SQL over JDBC. You need to analyze and fix them on the SQL and database level. When you do this, you will quite often recognize that you cannot implement the more complex or optimized SQL queries with JPQL or the Criteria API. In these cases, you need to use a native query to perform a native SQL statement. It allows you to use all SQL and proprietary database features. I explained native queries in great detail in another video. Let's have a quick look at a small part of it, and if you're interested, you can watch that video afterwards. I put a link to it into the video description. Creating a dynamic native query is quite simple. The Entity Manager interface provides a method called createNativeQuery for it. This method returns an implementation of the query interface, which is the same as if you call the createQuery method to create a JPQL query. The code snippet on the slide shows a simple example in which I use a native query to select the first and last names from the author table. And I know, there's no need to do this with a native SQL query. I could use a standard JPQL query for this, but I want to focus on the JPA part and not bother you with a complex SQL query. The persistence provider does not pass the SQL statement, so you can use any SQL statement that is supported by your database. In one of my recent projects, for example, I used it to query PostgreSQL-specific JSB columns with Hibernate and mapped the query result to POJOs and entities. Okay, let's get into the IDE and execute a native query. Here you can see the same query as I showed you on the slide. It selects the first and last name of all authors. You can use the query in the same way as any JPQL query. I didn't provide any mapping information for the result, and so the Entity Manager returns a list of object arrays, which you need to handle afterwards. Instead of mapping the result yourself, you can also provide additional mapping information and let the Entity Manager do the mapping for you. Here you can see the SQL query and the log messages written by the test case. As I said, Hibernate doesn't pass native queries. It just takes the query and executes it. That allows you to use all SQL features supported by your database. Okay, that's all for now. As I said, I provide you a link to that video in the video description so that you can watch it if you want to dive deeper into native queries. Tip number 3. Choose the right fetch type. Another common issue is the usage of the wrong fetch type. It is specified in the entity mapping and defines when an association gets loaded. FetchType eager forces Hibernate to initialize the association when it loads the entity. That can result in a huge number of additional queries. FetchType lazy, on the other hand, gives Hibernate the option to fetch the association only when you use it. Okay, that doesn't seem to be complicated. But the main problem is that you can only define one fetch type for an association. Hibernate uses it every time it fetches an entity from the database. So you either have only queries that have to request the same association, which I doubt, or you are not able to define the best fetch type for all of them. You need to choose the best default fetch type, which in almost all cases is FetchType lazy. Tip number 4. Use query-specific fetching. As I explained in tip 3, you are not able to define the optimal fetch type for all queries in the entity mapping. The good thing is that you don't need to do that. You only need to specify the optimal default behavior, which in most cases is FetchType lazy. You can then define eager fetching for the queries for which you need it. That allows you to prevent lazy initialization exceptions and to avoid n+1 select issues. You have multiple options to define eager fetching for a query. You can either do this as part of your JPQA statement by using fetch_join instead of join. Another option is to use a named entity graph. That is one of the new features introduced in JPA 2.1 and allows you to define a graph of entities that Hibernate shall fetch from the database. If you need a more dynamic way to define your entity graph, you can also do this via a Java API. Let's jump into the IDE and have a quick look at the different options. Here you can see an example with a simple JPQA query that selects the author entity with ID 1. Then I commit the transaction and close the session before I call the getBooks method on the selected author. This is the getter method of a lazily fetched relationship, and Hibernate will have to initialize it. Let's run this test and see what happens. As you can see here, the test fails with a lazy initialization exception because Hibernate isn't able to fetch the related book entities without a Hibernate session. So let's add a join fetch statement to the query to fetch the related entities. You can see the changed query here. I added a join fetch statement for the book relationship. This time, Hibernate initialized the relationship when it got the author entity from the database. It did that with this SQA statement that selects the required columns from the author and the book table. A fetch join is a good option if you want to define the eager fetching for one query. If you are looking for a reusable solution, which you can use with multiple queries, named entity graphs are the better option. It's an annotation-based approach to specifying a graph of entities which Hibernate shall fetch from the database. Here you can see an example of a simple named graph. I used the name graph.authorBooks and defined a node for the books attribute. That tells Hibernate to initialize the books attribute when it loads the entity. You can provide multiple named attribute nodes and named subgraphs if you need to define more complex graphs. The only thing you now need to do is to tell Hibernate to use this graph for your query. You do that in 2 steps. First, you need to call the createEntityGraph method of the entity manager with the name of the graph to instantiate an entity graph. You can then use this graph instance as a query hint. As you can see, the test case was successful. Hibernate generated the same SQL query as in the previous example. Your third option for query-specific eager fetching is to define the entity graph via a Java API. That is useful if you want to specify the graph based on user input. Here you can see the definition of the same graph as I showed you in the previous example. I instantiate an entity graph for the author entity and add an attribute node for the books attribute of the author entity. And then I provide the graph to the query with the same hint as before. This test was also successful. Hibernate used the entity graph to generate the same SQL query as in the 2 previous examples. Tip number 5. Let the database handle data-heavy operations. Okay, this is a tip that most Java developers don't really like, because it moves parts of the business logic from the business tier into the database. And don't get me wrong, there are good reasons to choose Java to implement the business logic and a database to store the data. But you also have to consider that a database is very efficient in handling huge datasets. It can therefore be a good idea to move not too complex and very data-heavy operations into the database. There are multiple ways to do that. You can use functions to perform simple operations in JPQL or native SQL queries. And if you need more complex operations, you can call stored procedures with a name stored procedure query or the corresponding Java API. Here you can see the definition of a named stored procedure query. I used the name calculate and it calls a stored procedure with the same name. The procedure is very simple. It takes two input parameters and returns the sum of them. You need to register all three of these parameters for the named stored procedure query. I do that here. X and Y are input parameters of type double, and the sum is an output parameter also of type double. That's all you need to do to define a named stored procedure query. You can now instantiate and call it in your business code. I do that here by calling the createNamedStoredProcedureQuery method on the entity manager with the name of the nameStoredProcedureQuery. Then I set the two input parameters, execute the query, retrieve the result, and write a short log message. As you can see here, the call of the stored procedure was successful. It calculated and returned the sum of the two input parameter. You can also define this stored procedure call via a Java API. It's pretty similar to the previous approach. This time I call the createStoredProcedureQuery method with the name of the stored procedure. Then I define the two input and the output parameter. The stored procedure call is defined now, and I can set the input parameters, call the stored procedure, and get the result. Tip number 6. Use caches to avoid reading the same data multiple times. Modular application design and parallel user sessions often result in reading the same data multiple times. It is quite obvious that this is an overhead that you should try to avoid. One way to do that is to cache the data that gets read often and not changed too often. Let's see which options Hibernate has to offer. Here you see the schematic representation of two Hibernate sessions and a database. Most developers have this in mind when they talk about using Hibernate to get data from the database. But it's a little more complex. There is the first level cache, which is directly linked to a Hibernate session and which is activated by default. It contains all entities which were used during a specific session, and Hibernate uses it to avoid additional database requests for read operations and to delay all write operations as long as possible. And then there's also the second level cache, which also keeps entities but is independent of the Hibernate session. That means that all Hibernate sessions share this cache. So session A can put an entity into the cache and session B can read it from there. It needs to be activated by configuring the shared cache mode property in the persistence.xml file. The caching of specific entities can be activated by adding the javax persistence cacheable or the org hibernate annotations cache annotation to the entity. The query cache is the only one which does not store entities. It caches query results and contains only entity references and scalar values. You need to activate the cache by setting the hibernate.cache.useQueryCache property in the persistence.xml file and set the cacheable property on the query. Caching is a complex topic, and you should be careful when you introduce it to your application. If you'd like to learn more about it, please have a look at my Hibernate Performance Tuning online training. You can find a link to it in the video description. Tip number 7. Perform updates and deletes in bulks. Updating or deleting one entity after the other feels quite natural in Java, but it is also very inefficient. Hibernate creates one SQL query for each entity that was updated or deleted. The better approach would be to perform these operations in bulks by creating update or delete statements that affect multiple records at once. This can be done via JPQL or SQA statements or by using the criteria update and criteria delete operations. You probably know how to write an SQL or JPQL update or delete statement. So let's get into the IDE and have a look at a criteria update. The definition of a criteria update statement is pretty similar to the definition of a criteria query. Here you can see a simple example in which I increased the price of all books by 10%. I first get the criteria builder from the entity manager and use it to create a criteria update instance for the book entity. Then I specify the from clause in the same way as I do that for a criteria query. In the next line, I define the set clause. I set the value of the price attribute to the product of its current value and 1.1. So I increased the price of each book by 10%. Then I create a query and execute it. That's all. Let's run this test and have a look at the log file. Here you can see a few log messages with the titles and prices of all books in my test database. Then I execute the criteria update and Hibernate generates this SQA statement that multiplies the price of each book with 1.1. And as you can see here, the next select statement returns the updated prices for all books. The criteria update triggered only one SQL statement to update all books in the database. That is a lot better than executing an SQA statement for each book entity. But there's also a downside to this approach. It doesn't update Hibernate's caches, so you either need to make sure that you don't cache any of the updated entities, or you need to invalidate your cache. As you have seen, there are several Hibernate features that you can use to avoid inefficiencies and to improve the performance of your application. In my experience, the most important ones are the Hibernate Statistics, which allow you to find these issues, and the definition of the right fetch type in the entity mapping and the query. I get into more details about these and other performance tuning tips in my Hibernate Performance Tuning online training. You can find a link to it in the video description. And before you leave, make sure to join my free Thoughts on Java library to download your Hibernate Performance Tuning cheat sheet, which summarizes the tips of this video. Okay, that's it for today. If you liked this video, please give it a thumbs up and subscribe below. Bye!